Welcome, ladies and gentlemen. Today we're going to be doing our Bohr model practice that takes place in our interactive notebooks. The first element we're going to start with is helium, which has an atomic number of 2. If the atomic number is 2, we know that the protons and electrons are 2 as well. Next, we're going to calculate the number of neutrons by taking the atomic mass 4 and subtracting the atomic number 2, which gives us a final count of 2. We will transfer this into our Bohr model on the left, where we have placed protons and neutrons in the darkened nucleus, while the electron count is marked off to the right. Next, we will begin placing electrons in the shells around the nucleus. The first shell around the nucleus of an atom, as seen from our notes, can hold 2 electrons. Because a helium atom has only 2 electrons, we will draw these in on our Bohr model, which will bring our total electron count down to 0, and will complete the Bohr model for the helium atom. Now let us move on to something a little more difficult, the calcium atom. Calcium has an atomic number of 20, which means it has 20 protons and 20 electrons. It also has an atomic mass of 40. To calculate our neutrons, we take our atomic mass rounded down 40, we subtract 20, and we are left with 20 neutrons. We can transfer this information into our Bohr model on the left, marking protons and neutrons in the nucleus and electrons off to the right. Next, we will begin placing the electrons in the shells around the nucleus. The first shell can hold 2 electrons, so we make 2 dash marks and we subtract 2 from our total. Even though we have placed the first 2 electrons, we still have 18 left. So we continue placing electrons in the next shell. The second shell around the nucleus of an atom can hold up to 8 electrons. So we will put all 8 of our electrons marked in the second shell. However, this will still leave us with 10 final electrons. As seen in our notes, we can fit up to 18 electrons in the third shell. Because 10 is less than 18, we will place all 10 of our electrons in the third shell, knowing that there would still be room to place electrons if we needed them. Because we have finished placing electrons for this atom, this Bohr model is complete. If we needed to count the number of valence electrons, we would simply count up the electrons in the outermost shell, which would be 10. Let's move on to the fluorine atom in our notes. Fluorine has an atomic number of 7, which means it will have 7 protons and 7 electrons. It has an atomic mass of 14, which when we calculate the atomic mass minus the atomic number, we get 7 neutrons. We can take this information and transfer it to our Bohr model on the left, placing the protons and neutrons in the nucleus and tallying up the electrons on the right. Knowing that the first shell can hold 2 electrons, we subtract 2 from the total of 7, leaving us with 5 left. Then we take the remaining 5 electrons and place them in the second shell, knowing that the second shell around the nucleus of an atom can hold up to 8. Because we have 5 electrons in the outermost ring of the fluorine atom, we could say that the valence electrons for fluorine is 5. Next, let's take a look at the iron atom. Iron has an atomic number of 26, which means it has 26 protons and 26 electrons. Its atomic mass must be rounded up to 56. We take the atomic mass and subtract the atomic number, leaving us with 30 neutrons. We transfer this information into the Bohr model on the left, labeling protons and neutrons in the nucleus and the total electrons on the right. Then we begin calculating for the electrons around the nucleus. We know from our notes that the first shell can hold up to 2 electrons. So we place our 2 electrons in the Bohr model, and then we subtract 2 from our total number of 26. We are left with 24 electrons. Knowing that the second shell can hold up to 8 electrons, we will fill the second shell completely and subtract 8 from 24, leaving us with 16 left over. Knowing that the third shell can hold up to 18 electrons, we take the 16 remaining left in this atom and place them in the outside shell. Because the outermost shell has 16 electrons, the valence electrons for this iron atom would be 16. Next, let's move on to neon. Neon has an atomic number of 10, which means it has 10 protons and 10 electrons. It has an atomic mass of 20. When we calculate for neutrons, atomic mass minus atomic number, we find that the number of neutrons is 10. We can take this information and transfer it to our Bohr model on the left, placing protons and neutrons in the nucleus and tallying up electrons on the right. Next, we begin by placing the electrons in each appropriate shell. The first shell can hold up to 2 electrons, so we take our initial number of 10 and we subtract 2. This will leave us with 8 electrons in our second shell. Because the second shell can hold up to 8 electrons, we will fill it completely. This will give us 8 valence electrons, and we'll also note that the atom is what we call stable, which means the outermost shell is as full as it can be. Next, we will model chlorine. Chlorine has an atomic number of 17, which means it has 17 protons and 17 electrons. Its atomic mass is 35. When we subtract the atomic number from the atomic mass, we can calculate our neutrons to be 18. We will transfer this information into our Bohr model on the left, with protons and neutrons in the nucleus and tallying up electrons on the right. Then we will begin placing electrons in each shell around the nucleus. We know that the first shell can hold up to 2 electrons, so we will draw them in on our Bohr model and then subtract 2 from our total of 17. This will leave us with 15 electrons left. We can take the next 8 of them and place them in the second shell around the nucleus of the atom, drawing in all 8 electrons around the model and subtracting 8 from 15. Now that we have filled the first and second shell, we can see that only 7 electrons remain. All 7 electrons will fit in the third shell of the atom, which can hold up to 18. This atom is now complete, and we can say that it has 7 valence electrons. Next, we will be looking at aluminum. Aluminum has an atomic number of 13, which means it has 13 protons and 13 electrons. It has an atomic mass of 27 once we have finished rounding. When we do our calculations, we can find that aluminum has 14 neutrons. We take this information and transfer it into our Bohr model on the left, placing protons and neutrons in the nucleus of the atom and tallying up the electrons on the right. Then we will begin by placing electrons in each shell around the atom. The first shell can hold up to 2 electrons, so we will draw them in on our Bohr model and subtract 2 from our total of 13. This will leave us with 11 electrons. The second shell of the atom can hold up to 8, so we will draw them in on our Bohr model and subtract it from our new total, which is 11. After we subtract the 8 electrons for the second shell, we are left with 3. 3 electrons will fit in the outermost ring. The third ring of the atom can fit up to 18 electrons. Because we have only 3 electrons in the outermost ring, we can also say that our valence electron number is 3. Now let's take a look at carbon. Carbon's atomic number is 6, which means it has 6 protons and 6 electrons. Its atomic mass is 12. We can calculate the number of neutrons by taking the atomic mass and subtracting the atomic number, which should give us a neutron value of 6. We will take this information and transfer it into the Bohr model on the left, placing protons and neutrons in the nucleus and tallying electrons on the right. Then we will begin placing electrons in the shells around the nucleus. The first shell can hold up to 2 electrons, so we will draw them in on our Bohr model and subtract them from our electron total, which is 6. This will leave us with 4 electrons. 4 electrons will easily fit in the second shell, which can hold up to 8. Because we have only 4 electrons left in our outermost shell, the valence number of electrons for carbon will be 4. Our final atom that we will be drawing a Bohr model for today is sodium. Sodium has an atomic number of 11, which means it has 11 protons and 11 electrons. Its atomic mass is rounded up to 23. We can calculate the neutrons, subtracting the atomic number from the atomic mass, to calculate 12. This information is then transferred into the Bohr model on the left, placing protons and neutrons in the nucleus and tallying electrons on the right. Then we will begin by tallying up the electrons in each shell around the nucleus. The first shell can hold up to 2 electrons, so we will draw them in on our Bohr model and subtract them from the total number of electrons, which is 11. This will leave us with a total of 9 electrons, 8 of which can fit in the second shell. Draw these in on your Bohr model and subtract 8 from your new total, which is 9. After we have accounted for the electrons in the first and second shell, we are left with only 1 in the outside shell of the sodium atom. We place this 1 electron in our diagram, and we can say that the number of valence electrons for sodium is 1 because it is the only electron in the outside shell.